Hello. Now today we're going to be dealing with compound angles. So sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b, so on. So the sum and difference inside the angles. Now these formulae are on page 14 in your log tables. So if you see anything that involves cos or sine or tan of a plus or minus b, you immediately open up page 14 in your log tables and you see what tools are available to you. If I'm asked about an identity like this, I'm going to leave the tan A and tan B alone, and I'm going to see if I can simplify this stuff down. The reasoning is mostly that the tan A and B doesn't have any sum of angles. So I'm going to try and simplify this thing down to where it just has sine and cosine of A or B. So no complicated stuff going on inside of the brackets. Now, from page 14, I see this sine A minus B, and I go to page 14 in my log tables, and I see that sine of A minus B is equal to sine of A cos B minus cos of A sine B. This is on the, or in the log tables on page 14. Now, lines just here mean this isn't part of the sum. This is a reminder for myself. I'm about to do this substitution because this only has A's and B's separated in separate little sines and cosines. So it's simpler. I'm simplifying it down. I'm getting rid of complicated stuff like the sum or the difference inside of my sines and cosines. And I'll see if that allows me to cancel things to get down to what I want on the right hand side. So let's do this substitution in here. So I have sine A cos B minus cos A sine B, and all of that is divided by cos of A cos of B. Now I can see a difference of terms in my numerator, and I have a common denominator here obviously, and I see I have two separate terms here. So what I'm going to do is break this up into two fractions that are subtracted from each other. So I end up with sine A cos B all over cos A cos B minus cos A sine B all over cos A cos B. Now I have two separate terms, and I see if I can cancel some stuff down, and I can see fairly blatantly that I can. I have cos B all over cos B, and I have that multiplied by everything on the top and the bottom, so I'm able to divide out common factor. And I have cos A top and bottom here, all multiplied by everything on the top line and everything on the bottom line, so I'm able to divide out a common factor, and I end up with sine A all over cos A minus sine B all over cos B. And this is, by definition, tan A. And this is, by definition, tan B. And that is what I was asked to show on the right-hand side. So that works out. So again, the general principle is whichever side is simpler. It may come up that you have to simplify both sides, but in the most cases, what you will end up with is you'll end up with one side that is more messy than the other. It'll involve things like the difference of angles inside a sine or a cosine. You simplify that side down as much as you can. So do your substitutions from the log tables, try and divide out any common terms, see if you end up with anything funny like sine squared or cosine squared that you know that you can do substitutions for, and work your way down until you end up spotting that you can turn it into what you want on the other side. Now, this type of question or the types of questions we're doing here, can be combined with certain types of number angle questions. So here the angles are just given to us as letters that we could sub in. So A could be 30, B could be 65. We haven't been given that here, but we could be. And often, if we do get numbers, they will be in the context of our special angles 30, 60, and 45 that are on page 13 in your log tables. So if you get a number angle type problem and you're asked to solve it without using a calculator, almost always you will be dealing with a situation like this, where we are going to page 13 in our log tables, and there's a table on page 13 that gives you all of your different possible angles that you can sub in, the different values for sine and cosine for the sine of 60, 30, and 45, and so on. Now, let's put this into practice. So we have sine of 105. So sine of 105, and I want to find out what that is equal to without using a calculator. What we have to recognize is that we can turn this into a sum of angles. So there aren't that many options that you can end up with, and you'll learn to spot them quite quickly. Also, if they tell you to do this without using a calculator, you're pretty much guaranteed that you're dealing with sums or difference of 30, 60, or 45. Now, 105 can be broken up into sine of 60 plus 45. There are other ways you can break it up too, and they'll give you the correct answer as well. But if we break this up into sine of 60 plus 45, then you can use, now I have the sum of angles, sine of the sum of angles is going to be sine of, I go to page 14 in my log tables, and I have sine of A plus B. The situation I've got now is equal to sine of A cos B plus cos of A sine B. And my A is going to be 60 and my B is going to be 45. Now, again, why have I broken this up into 60 and 45? Because on page 13 in the log tables, it gives you a table that gives you all of the solutions to sine, cos, and tan for our three special angles, as well as 90 and 180. Now, let's do our substitution. So we have sine of 60, sine of 60, cos of 45, plus cos of 60, sine of 45. Now I go to my log tables, page 13, and read off from the table sine of the angle 60 is equal to root 3 over 2. Cos of the angle 45 is equal to 1 all over root 2. Cos of 60 is equal to a half. And sine of 45 is also equal to 1 all over root 2. Now you can read these from the diagrams here as well, but you do have them available to you in the log tables. When we multiply that out, we end up with root 3 all over 2 root 2 plus 1 all over 2 root 2. We can add that up. We get root 3 plus 1 all over 2 root 2. They may in the exam ask you to give this with a rationalized denominator. This would be a perfectly fine answer if they didn't give you any restrictions, but it's possible that they could ask you to rationalize the denominator. So just to remind you of how it is you do that, you have a root 2 here. We don't want to have any square roots underneath the line. So if I multiply root 2 by root 2, I would end up with 2. So what I'm going to do is multiply above and below by root 2. Again, this answer would be perfectly valid unless they told you to give your answer over b, where b is a integer, or told you to rationalize the denominator directly. So we have root 2 by root 3 would be root 6, plus 1 by root 2 is just root 2, all over 2 by 2. So we end up with root 6 plus root 2 all over 4. Again, unless you're specifically asked to rationalize the denominator or give it in the form where you have an integer underneath the line, you don't need to do this last step. It's just to remind you of how to rationalize the denominator. So that's what we need for compound angles, where we are adding or subtracting inside of our sine, cos, or tan brackets.